Hi, this is Subhas. My project was done in National Atmospheric Research Laboratory, Department of Space, Government of India in NRL. My project title was Latitude Difference Nocturnal Plasma Drift Velocity Variation. Abstract. We investigate one of the most energy-meant feature of equatorial ionosphere known as equatorial plasma bubble using the monitoring of faint airflow emission during night time. This feature can be captured with the help of air glow imaging data of 630 nanometer oxygen emissions. We have found large difference in the drift velocity from one latitude to another. This is important for the navigation community as the electron density variations affect the trans-ionospheric communication satellites. Such large electron density variation cause significant in communication. Next, overview of project. Step 1. Imaging, cropping and enhancement. Step 2. Gradient calculation and plotting. Step 3. EPG moment calculation and plotting. Step 4. Result and discussion. Next, our existing system. As known, the drift velocity is calculated at the zenith axis. Tori and Scindia has proposed the drift velocity calculated by the gradient. Next, proposed system. In this project, we have proposed that the drift velocity variation is varied in this latitude. 5 different latitudes drift velocity calculated and the result compared with gradient value. Next, introduction. The atmosphere is a layer of gases which surrounds the entire Earth. It consists mainly of nitrogen 78.08%, oxygen 20.95%, as well as few other gaseous elements. Troposphere starts at the ground, ends somewhere between 7 to 14 kilometers. The higher the colder, weather in this layer affect our daily life. Stratosphere starts at 7 to 14 kilometers, 4.3 to 8.7 miles. End at 50 kilometers. Mesosphere starts at 50 kilometers, 31 miles. Ends at 80 or 85 kilometers. Thermosphere starts at 80 or 85 kilometers. Next, ionosphere. The ionosphere is a region of upper atmosphere where charges, both positive and negative, exist in quantities large enough to influence radio waves. The D region is the lowest region in the ionosphere, which is located at altitudes between 65 kilometers and 95 kilometers. Next, ionization. Radiation from the sun causes ionization in the ionosphere. Electrons are produced when solar radiation collides with uncharged atoms and molecules. Since this process requires solar radiation, production of electrons only occurs in the daily light, the hemisphere of ionosphere.
Pause.
Equatorial plasma bubble. You can see the image that we have captured that image in side by side. Instrumentation. In this instrumentation, we are using these equipments, hardware equipments: optical system, image control system, fisheye lens, interference filter, CCD camera, and other equipments are software equipments: Image Version Pro 8, MS Office. All-sky imager system. This is the image that we are used to capture the image from the This is the software we are using this. First, filter 1, filter 2, filter 3. Filter 1 recommends to filter the image and crop the image, and filter 3 are using to image crop data. Methodology: image analysis, gradient observation, drift velocity observation. Image analysis. We have separated these 3 images. First, raw image data, crop image, enhancement image. Gradient calculation. In this software, we are using Image 2S to calculate the drift velocity gradation. Next, gradient plot. In this plot, we are using the origin software to plot the gradient. Drift velocity calculation. From the zenith axis, we are calculating the center point of the axis to calculate the answer. Drift velocity variation. Time and variance should be important to sheet and produce the answers. Result and discussions. We have calculated the drift velocity for the different latitudes by the moment of structure towards eastward and determined the result that they are at each latitudes. Thank you.